We're going to take a little bit of a broader approach, I think, today, talking about big data technology in general, a little bit about the analytics, and but mainly just kind of a level set of where we see the big data space and how people are starting to utilize it, particularly in this industry, but in others as well. So
we see and have worked with a lot of the industry's leaders over the years as they turn data into analytics, into actionable things that they can do in the business to really improve the business. And so with the advent of big data, there certainly is a lot of hype and a lot of confusion. And one of the things that I like to do when I go out into venues like this is talk a little bit about what we see and how these things are working together. One of the things that I hear a lot about is big data is Hadoop, and Hadoop is big data. And so just by way of level setting, big data is very confusing, and in fact I wish the industry would come up with a better name, because a lot of folks say, well, big data is about big volumes of data, lots of data. And in our mind, actually, that has absolutely nothing to do with what big data really means. Certainly large volume, large amounts of data is something that we're not strangers to, having actually begun in the early 80s as a very scalable database platform. We have customers, our largest customer instance today is 87 petabytes in a single instance of a database. So we do big data, right? But that's actually not what's particularly interesting in the advent of big data or even Hadoop or any of these buzzwords. It's really about the new kinds of data that are available, data that didn't even exist maybe a year, 2, 5 years ago, that are now available. And then some people say, well, big data is unstructured data. And in fact, for those of us who are kind of in the computer science industry, unstructured data doesn't compute, right? Because all data actually have structure. You just might not know what the structure is, and the structure may vary. Or it may not be typical, it may not be relational, which is the way a lot of us have thought about data, including myself, for a very long time. So it's really, and it's not a product, right? It's not just Hadoop, but I do believe Hadoop is really an enabler, and I put this slide in here to really just talk about Hadoop is an enabler because it allows us to see data in a different way. Let me explain what I mean by that. Having been through the data wars for very many years, one of the things that has really allowed us at Teradata and data warehousing and business intelligence over the years to become very successful and almost de rigueur in IT organizations is that if you're able to collect data from your business and store that data logically without applying any specific rules to the data, and then look at that data and give your users freedom to look at the data, they can actually get insights from the data that allow you to then drive better decision making and drive your business. And the key to success there is keeping all of the detailed data, not making any changes to it, not applying any rules to it, but just keeping it for analysis, keeping it in its native and logical form. Because of course, if you apply rules and then you run an analytic, the answer you're going to get is the rule that you applied to the data, so you haven't learned anything. What's really cool about Hadoop, and bringing it back to what I really believe is interesting in big data, is new kinds of data with new structures, many of which you don't know what they are, right? Trying to shove that into a relational database means you're going to have to apply rules and change it and maybe keep a summary level. And what's really great about Hadoop is you can just keep the data exactly as the data work for future analysis. It also provides a tool set, a different kind of tool set for running analytics, okay? So that's really great. Now, this is my buzz chart I want to talk about, but Hadoop isn't big data, and it's not, and big data is not a product, it's not a solution, it's really an environment, and it's a new way that we all need to think. So what I've got here actually is on the top. This is a slide that was shown at Hadoop Summit in New York a couple of months ago. And it shows search hits on Hadoop versus SQL Server and Oracle, right? And the obvious implication is, oh my God, Hadoop is taking the world by storm. And in fact it is, and it's interesting, but actually the bottom chart is if you actually took those charts and used the same scale. And Hadoop is the blue line that you can barely see at the bottom. So it's gaining a lot of momentum, and it's really interesting, but it's just one of the many components of an overall strategy. The other thing is, this is a bit of a survey that we've done with some industry analysts talking about, well, why are you adopting Hadoop? Why is Hadoop interesting? My actual favorite one is the bottom one. It only got a few votes, but CEO read about it on a plane. I can't tell you how many times I'll go out and talk with customers, and we'll be talking about the big data strategy. And the big data strategy is, my CEO cornered me in the elevator and said, what's our big data strategy? So I went and bought some Hadoop, and I'm storing big data. Great. But more seriously, a lot of the other things that we see, right, in here is cost containment, right? It's cheap, open source, cheap servers. So in pressured IT budgets, this is actually a really interesting thing, right? But the other thing that's really important in a lot of the adoption is flexibility, the flexibility that the environment creates. Now, flexibility is really great, and sometimes in traditional BI and data warehousing, we become victims of our own success. We're closing the books using the data warehouse. We're driving pricing strategy based on inferred demand, based on our supply, based on what we've sold, and we need to do that, and it's a very rigid process that's been built, and it's very successful. It helps us optimize our profits, it helps us get better consumer loyalty, all those kinds of things. If you're closing the books with a system, however, you probably don't want to let a developer on that system just to play around and do whatever he or she wants to do. So it becomes very inflexible because it's very successful. So flexibility and cost tend to be some of the big real driving factors beyond the CEO read about it on a plane. But the state of the industry is that we're not seeing a lot of companies who are yet deriving huge amounts of value from the investment that they've made. And so kind of it's in this context that we look at big data and say, well, what does this really mean? And how can we help advise our customers, and how can we learn from our customers in creating success out of big data? And so I'm just going to skip forward a little bit further. One of the big things that I always get asked, because I represent a traditional data warehouse company, is, was Hadoop going to take over and replace databases? And the answer is absolutely not. It's a different tool with a different purpose, with different advantages, and sure, it's open source, which means certainly the product cost is very low, and that's interesting. But open source software is kind of like someone giving you a free puppy for Christmas, right? That free puppy really isn't going to be completely free. And when you look at the cost of analytics and the value that's driven from analytics, product expenditure is actually one of the smallest expenditures that your enterprises will make. When you add in all of the other costs, like plugging the servers in and keeping them cooled in the data center, like all the human beings that run around managing the data movement and doing data cleansing and building the applications, when you look at that total cost, it's really only a small sliver. So that's kind of a misnomer. But what's really interesting is that combining it with traditional databases and extending analytics is where we're seeing customers derive the most value. And I'll dig a little bit more into that. This slide represents victims of our own success. Sadly today, I was advised to wear jackets, so I look like the one on the right. I didn't wear my hoodie today, right? But there's this whole movement, and again, this gets to the notion of flexibility. Data is easy to move, easy to manage. There are open source tools. I can download them, I can play, I can be creative, and I can learn new things. Hackathons, right, are really big. Do you want a hackathon running on your general ledger system? Probably not. So things are very different, but there's power when you can combine those things together in an environment that allows flexibility and structure to commingle and coexist. So again, in the big data hype, what we're focused on is taking the technology and the advantages and the data and the use cases and getting from data to insight to action. Because it's really interesting to store all of the weblog and web traffic data forever in a Hadoop cluster because it's cheap. So what? What do you do with it? How do you leverage that? How do you use that? How do you integrate it? How do you turn that into an insight? But more importantly, once you get that insight, how do you get it to take action in your business that's actually going to make a difference? And so what we've been seeing and what we've been building around, and I'll introduce you to the concept of, is really this notion of a unified data architecture that includes big data, new data, Hadoop, as well as traditional data, traditional MIS systems together in a way that the components that are combined are actually worth more than the individual parts, because they allow the flexibility, the freedom, the new analytics, they allow better insights, but most importantly, by having all of these systems work together in a common architecture, they allow us to take big data insight into actions that get taken inside of a business. And since we've rolled out our unified data architecture, which is a set of products and solutions and consultancy around implementation, we've actually seen, of our 1,200 traditional Teradata data warehouse customers, we've seen now almost 100 adopt a unified data architecture and begin down their path. And this is something that we're really seeing accelerate. And it's not so much a, I mean, by the way, I'm thrilled. I'm thrilled that if our customers are successful, that's going to be really good for Teradata, and of course that's what I'm mostly interested in. However, at a level beyond that, what we're seeing is our customers are actually now starting to be able to deliver demonstrable value from big data. And instead of getting that question of, gee, what's our big data strategy? Oh, I bought a Hadoop cluster. They're now able to say, well, we've been able to increase customer loyalty. We've been able to reduce customer churn. We've been able to improve our conversions on the website. And here are the statistics that can show it. And so that's actually quite rewarding for us. So the notion behind, and I'm sorry if it's not showing with the lights very well, behind having a unified data architecture rather than a data warehouse or Hadoop or something is really about looking at the different kinds of data, the different kinds of analytics, and the different kinds of technologies and what they offer, and really creating the right tool for the right job. And growing up, my grandfather was very handy, and I always thought he could build a house if he had a saw and a hammer, and he probably could. And that would be really cheap. That would be the equivalent of running your entire data strategy perhaps on Hadoop. But you could build a better house if you had, a level and a cement mixer and a drill and all of the other tools that are required to do different jobs in a very effective fashion. And so there are a lot of trade-offs in this new world. There is cost. There's cost of storage, but then think about that cheap cost of storage versus the cost of processing. And sometimes one technology is very cheap in storing data, but if you actually try to use that same technology to do any processing of the data, it actually becomes very expensive. Conversely, there are some technologies that are very inexpensive from a processing perspective, but the dollars per terabyte are more expensive. And that's because they've been optimized for different things. The persistence of data, data quality, data lineage, and the use cases also come into play. And so my point is, it's not a one-size-fits-all kind of scenario in this big data market. However, it's really important to figure this out because the way I think about it, having been through the evolution of the first data marts into enterprise data warehousing, into real-time operational data stores, and now into big data, I really view this as the biggest transition that we have available in our industry in terms of what we can provide back to our business consumers in the value. So if I roll forward here, there are different constituents in the end that you need to get talking. And so this is not a Teradata employee, but we call it data artist. And some of you have probably heard the term data scientist. We've actually been talking more about data artists because data scientist sounds too much like just a statistician or just a physicist or just a numbers cruncher. And one of the things that we're seeing is that our customers who are very successful in deploying their big data strategies have a couple of these data artists. And they're a combination of explorers, creative thinkers, as well as very smart, data-savvy people, right? And they have certain needs and certain things. And by the way, these folks really want flexibility, right? Give me the data, let me put it under my desk, don't talk to me, I don't want to have to call the IT police and ask for access, I don't want to have to check it in or check it out, I don't want to have to fill out a report. Just give me the data and leave me alone, right? They also like to roll their own. So I'm happy to roll my own tool, download an open source tool, write my own code. If it doesn't work, I want to fail fast and go do the next one, right? So they're not really structure-oriented, but they can show up with some of the most interesting use cases that never existed before by looking at data in a different way, okay? But they have very specific needs. Now, at the same time, these folks are extremely hard to find. I don't want to put you specifically on the spot, but do you all have data scientists or data artists in your organizations? Do you know who they are? I'm glad you guys do. That's good. They're hard to find, and they're hard to keep, and they're extremely scarce and expensive resources. So one of the other things that we're finding is the advantage of a unified data architecture is allows our customers to create these environments so that they can use these scarce resources and let them focus specifically on the job at hand, but not be encumbered by creating visualizations, by creating the productionalization of their algorithms. Give them the data, let them find the algorithm, and let them pass it downstream then to someone who can then productionize it and turn it into actionable information, and therefore save that very scarce resource and allow them to be extremely valuable. We see a lot of our customers have business analysts. Now, these folks have very different needs. They're not programmers, but they're very analytical people. And they want access to all of the data as well, but they need a different level of tools. They're not going to write the code. They don't want to do Java programs or download some open source. They want some structure and some tools, but again, a little bit of flexibility. So, and we see our customers, if they have 3 or 4 data artists, or 5 or 6, and in some extreme cases, a few more data artists, they'll have hundreds or even potentially thousands of business analysts. So this is a less scarce resource, but a very important resource with different needs in the entire big data scheme. And then finally, there's the business consumer / executive, impatient. They were going to, some of my employees actually put my picture in here because it said impatient, and I took it back out. Just the facts, and they're very operational, right? So I don't want to mess with any of this. I just want to know what is the answer, right? And so now you've got to serve these 3 constituents in a big data space, and that's where we really see the emergence of the need for a unified data architecture. And you'll notice that on here I've actually put no product names, although certainly your friends here at Teradata have products that fit into most of these boxes that we'd love to talk with you about. But the key is that there are all kinds of varied data sets coming around. It's not just the ERP system or the CRM system anymore, but in fact there may be images and text and the web logs, machine data, sensor data, data just everywhere coming into the environment. And on the other end, there are all these different constituents of users that have different needs. And what we're saying is it's really not a one-size-fits-all in the big data space, and it's important to consider what you put kind of in between. And the way we see it falling out is that there are 3 discrete data platforms that need to communicate and integrate to make this thing work effectively and serve all of the constituents that you have in your business, and do it at the total operating cost. Okay, so it's not just one tool, but the total operating environment. And so in here, we've obviously got the data platform. The data platform you could read as Hadoop, right? Where can I just put all of this raw material that I'm going to go mine later, right? What's important about storing raw material? Don't change it. Keep it the way it was, right? And keep as much of it as you can. So the implication, of course, is low cost per storage, right? And the flexibility of being able to store the data in a non-transformed kind of sense. So having that data platform, some companies are calling these data lakes or data oceans. And this is a really growing space in the end-to-end analytics business. Obviously, the integrated data warehouse, this is where Teradata has lived for the last 15 or 20 years. And the idea behind an integrated data warehouse is structured relational data that is actionable, that is traceable, that has privacy and security implemented. This is where you keep those customer transactions so that when your agent is talking with a customer on the phone, you know everything that happened up to the last second, so you can actually have a meaningful conversation with that customer. There are implications of that technology. Processing and data integrity are extremely important, right? Data volume in the integrated data warehouse is potentially going to be a couple of order of magnitude smaller than your data lake, right? You're not keeping all of the weblog traffic and images and voice and text for the last 20 years. You're keeping the relevant transactions so that you can communicate with your customers, or the relevant transactions so that you can close your books and so that you can communicate with your auditors. And you want to do that in a way where you have traceability of all of the data. The tool set for that is very different than the tool set for your data platform. The other key thing that we're seeing is the emergence of this discovery platform. It's not a in-between, it's not above or below. In fact, we have one of these that actually moves so that you don't get the implication one thing is higher than the other or anything. It's just things that have to work together. And what we're seeing is with the scarcity of data artists and all of the things going on in that space, our customers who are getting the most effective yield on their big data investments have also invested in a discovery platform of some sort. And the characteristics of the discovery platform are, it's a platform that combines the data platform characteristics of being able to have the data be stored in relational or non-relational format with late binding schemas. You probably hear of late binding a lot in the big data space. Or changing schema kinds of data, or data that is schema-less, right? A weblog is kind of schemaless. It's a bunch of characters that kind of imply what Scott did on your website, and you have to have some knowledge of how to traverse that data to understand what's the path, or what's the pattern, or what did Scott do, and also then tie that back to the outcome of the transaction and who is Scott in your integrated data warehouse. So the discovery platform also requires some of the sophistication of traditional BI and visualization tools, but unconstrained by relational theory. And so we're seeing a lot of customers use the discovery platform, and I have a couple of use cases that I'll show you that have actually been derived from the discovery platform. The other thing that the discovery platform allows you to do is create repeatable process. So the data artist creates the algorithm or sees the pattern or the signal in the noise that is all of this data in the data platform, hands it off to a business analyst who can now use the discovery platform to further refine it. And the data artist can go figure out how to invent the next great algorithm or look for the next great undiscovered piece. Once you, in the discovery platform, have found a pattern or a new analytic and you want to make it actionable, you need to get it into your data warehouse, because that's probably what gets to your frontline marketing folks, call center operations, or finance folks who are managing your general ledger. So there are these three discrete platforms that are important for success, and we see in our customers who are getting yield out of their big data investment, they have some or all of these three things, and they figured out how to make these things work together. And in many instances, of course, they've done this with Teradata. So, not to leave you completely confused, there's a lot going on so what I showed you before is really not a product view, but it's just a logical view of how I think you should think about your data platforms and your big data investments. There are, however, some other cool things going on which make all of that even more complicated to go traverse. Certainly, there's a lot of cloud mandates. And so what data do you put in the cloud, and what data do you put on site, and how do you move the data back and forth, and how do you maintain security and privacy between your cloud instance and your non-cloud instance? In-memory technology is creating some really interesting new performance capabilities out there. Processing and storing data is getting cheaper, so it's really easy to fall into an endless data ocean or data lake. And how do you decide how big that data ocean or data lake should really be? And then there are a whole lot of new analytics out there and analytic processing, like algorithms in R, many of them in open source, that need to be applied to the data. So when you're building out your unified data architecture, it's also very important to consider these technology trends and where you can most effectively use them to drive the best analytics and the lowest cost. I'm going to segue to some of the success stories. This is a path analysis, so online hotel reservations, right? And so this gets back to looking at weblog information. And in the traditional RDBMS world, we've looked at weblogs for a long time. However, the way we've looked at it is we've gone to the weblog and we've extracted certain pieces of information from the weblog and we've represented it as a table. Unfortunately, that takes away a lot of the intelligence that shows up on this, where you actually want to understand a path. It's hard to represent a path in a relational model. You can actually do it. I've been doing SQL since I was in short pants and crawling. I could probably do it, but it'd be really hard, okay? The point is, this is new data, a new data structure, and a new analytic, creating a path, and then a new visualization to allow your business analyst to understand what is the path that gets to reserve and book. And how do I understand the customers, where did they enter, where did they end? Of course, I want to make sure that they end and actually book something. So what are the characteristics of that? And how do I overlay tens of millions or hundreds of millions of transactions to look at the pattern? So what this is actually a heat map of the path, where you can see the thickness of the line is how many customers went down that path. And there's also color coding and other visualizations available. My point is that you need a data lake to store the weblog data. You need your integrated data warehouse to understand your customers so you can take action on this. And you need a discovery platform to create the tools to deliver this kind of insight. And obviously what we're finding here is the customers, one of the examples is, this is obviously a good outcome. We can see a lot of folks who came here actually went there. So what can we do to redirect this pattern down to here, right? And figuring that out and getting a 0.5% change can make a huge difference in your business, right? So it's new data, and you can only get this because you have all of the weblog data, right? Which is structureless, schemaless. The schema is different with each weblog, but you need to be able to represent it and then put it into a visualization. This is a similar path or pattern analysis we're seeing in this industry for reward customer behaviors and trying to understand how they're going to behave better, and again, getting better loyalty, getting better lift and better yield out of the investments that are made in customer loyalty programs. And the final use case, which is probably one of the biggest and most economically viable use case and the result of having a unified integrated data warehouse, unified architecture, is marketing attribution, right? And the way to think about it is how many billions of dollars are being spent on digital marketing, and how much is that growing with the advent of the Googles and the online booking agencies and all these other things. So if I do a Google search on a city for a hotel and then I click through it and I reserve from your hotel, you're going to give Google credit for sending me you, and you're going to pay them, right? But is that really the best use of your money? Well, I don't know. You might want to consider, do I already know who Scott is, and he just Googled it because he wanted to see a map to see which hotel was closest. And so maybe Google isn't that valuable. It was just a means to an end, right? And so digital marketing attribution, which allows you to keep all of the data, all of the cookies, all of the weblog traffic, and integrate that with your data warehouse where you've got customer loyalty information, and also obviously you've got your supply and inventory positions and your pricing algorithms, allow you to actually combine all of those things to do a better attribution of those billions of dollars that are being spent in a digital world, and even potentially redirect customers to more profitable channels over time. And we're seeing our retail, hospitality, travel, and transportation customers take advantage of this capability today. So I am officially out of time. I apologize. I talked really, really, really fast. A couple of key things. Big data is not just data volume. Big data is not a product. It's not Hadoop. A big data strategy is not buying a bunch of servers and storing it. It's really turning it into action. So you should consider your architecture, and I think you'll land in a similar position to the picture I showed, with a data platform, a data warehouse, and a discovery platform. And the use cases that you'll be able to derive will, I think, create even more value than BI created in the 90s and early 2000s. Thank you very much.